Most of the budget decisions in my house get made by my wife, but occasionally she actually trusts me to make some decisions on my own. Like when she sends me to the store at the beginning of every academic year to replenish my wardrobe. Last year she gave me $200 and sent me to Walmart. She told me I could spend it on shirts and pants, which is what I needed in my closet. So when I left the house for Walmart, I knew I had $200 I could spend. But in order for me to know how many pants and shirts I could afford, I also needed to know how much they cost. So when I got to Walmart, I found out that pants cost $20 a pair, and shirts cost $10 each. So one possibility was for me to spend my entire budget on just pants. $200 at $20 per pants would allow me to buy 10 pants with no money left over for shirts. This is illustrated as Bundle A in the next panel. We're using the horizontal axis in this graph to measure the number of pants, and the vertical axis to measure the number of shirts. Point A therefore contains 10 pants and no shirts. It's an extreme bundle in my budget, because it doesn't contain any shirts, and it would imply that I'd run around bare-chested for the next year. It's a bundle I'm unlikely to pick, but it is one that is affordable. There's of course another extreme bundle, which is that which contains only shirts and no pants. With the $200 that my wife so generously gave me, and the Walmart price of $10 per shirt, I could afford as many as 20 shirts if I was willing to forego wearing pants for the year. This second extreme bundle is illustrated as Bundle B in the next panel. In later chapters, we'll refer to points like A and B as corner solutions, because they're bundles that lie at corners of our budget constraint. Since I don't generally leave the house without pants or shirts on, I'm not going to pick either one of those. Rather, I'm much more likely to pick a bundle that lies somewhere in between A and B. For instance, I might be the kind of person who wears pants 2 days in a row, but I change my shirt every day. In that case, I might be more attracted to a point like 10 shirts and 5 pants. 10 shirts will cost me $100 since they cost $10 each, and 5 pants will cost me $100 because they cost $20 each. So the bundle of 5 pants and 10 shirts costs $200 and is therefore affordable to me with the generous budget my wife has given me. This is illustrated as Bundle C in the next panel. If I really wear pants twice as long as I wear shirts, owning a bundle like C makes a lot of sense. But buying the Bundle C may not make sense if I already have a bunch of shirts hanging in my closet, and what I really need more is pants. In that case, it may make more sense to buy a bundle like D, a bundle that contains 6 shirts and 7 pants. This bundle is also affordable for me because 6 shirts cost $60 and 7 pants cost $140, for a total of $200, which is exactly how much I have in my wallet. Notice that points C and D not only lie in between A and B, they appear to lie on a line that connects A and B, as illustrated in the next panel. This blue line is called the budget constraint, or sometimes we will call it the budget line. It contains all the bundles of pants and shirts that I'm not only able to afford, but at which I will have no money left over to bring back to my wife. Of course, I don't have to spend that whole $200 on pants and shirts. Maybe I'll have some money left over. Maybe I'd like to spend $20 to buy some roses for my wife on the way home. In that case, I might buy a bundle like 5 pants, which cost $100, and 8 shirts, which cost $80, with $20 left over. This is illustrated as Bundle E in the next panel. We will say that a bundle like E lies inside the budget constraint, and, just like all the other shaded bundles in this graph, it is not only affordable, but also leaves us with some money left over at the end. Together, the shaded area and the blue budget constraint constitute what we call the choice set or the budget set. This set constitutes all the bundles that are affordable to me, given that I have $200 and given that Walmart charges $20 for pants and $10 for shirts. Any bundle outside of this set, any bundle to the northeast of the blue budget line is not affordable to me with my budget and Walmart's prices. We know how to make sense of the vertical and horizontal intercepts of the budget line at points B and A. Those are simply the money budget divided by the prices of the goods that are measured on these axes. But now we want to also make sense of the slope. To do this, imagine that I currently have bundle C in my shopping cart, 5 pants and 10 shirts, and I suddenly remembered that I actually have a few more shirts in my closet than I previously thought about. So now I want to get one additional pair of pants. In order to get that pair of pants, I'll have to put back 2 shirts, because pants cost twice as much as shirts. Giving up 2 shirts beginning at point C moves us down to point E, and then getting one more pair of pants moves us to point F, which is illustrated in the next panel. So in order to get one more pair of pants, I have to give up 2 shirts, which is why we say that the opportunity cost of a pair of pants is 2 shirts. Starting at point C, giving up 2 shirts means going down to point E. Getting one more pair of pants means going over to the right to point F. This also tells us what the slope of the budget line is. We have to go down by 2 to go over by 1. The slope of any line is the rise over the run, and the rise as we go from point C to point F is -2, while the run is +1, giving us a slope of -2. This is why we say that the slope of the budget line tells us the opportunity cost of the good on the horizontal axis in terms of the good on the vertical axis. Our good on the horizontal axis is pants. Our slope is -2. So the opportunity cost of a pair of pants is -2 shirts, which is our good on the vertical axis. Of course, you could also calculate the slope from any other 2 points on the budget line, point B and point A, for example. As you go from B to A, you go down by 20 and over by 10. That gives us a rise of -20, and a run of 10. -20 divided by 10 is again -2. Finally, note that the reason that the opportunity cost of pants in terms of shirts is -2 is because pants are twice as expensive as shirts. That's the reason why the slope of the budget line can also be expressed as simply the price of pants divided by the price of shirts. 20 divided by 10. Or more generally, the price of the good on the horizontal axis divided by the price of the good on the vertical axis.